But yes, good morning, welcome. In the chat, we'd love to just know how many of you are joining us for the first time. If you want to put a 1, if this is your second session with us, put a 2. If it's your third, put a 3. And if you have been with us for all 4 sessions, drop a 4 into that chat box. All right. I thought Nanette might be an unfamiliar face for us. So Nanette, welcome. So nice to have you. So glad that you could join us today. And just so you know, if you want to reference any of our former sessions, we do have all of that recorded, and we're happy to share those with you towards the end of the session. So awesome. Got lots of lots of returning.
Welcome back for those of you who are 2s and 3s. We're so glad to have you back.
Mm-hmm. And all 4s, yeah.
Yeah.
Jessica and Danita. Perfect attendance. All right, so I think everybody that had been in, I had the chat, or excuse me, the sign in available for you, but please do make sure to sign in. And as Solana mentioned, don't worry about the fact that the date might say April. It will when you submit, timestamp it for today. So all good there. Right.
All right, so if you are new to this group, we'll just do a quick kind of brief overview of what this series has been about. If you've been with us from the beginning, this will look familiar, but essentially with this series, we've addressed kind of 4 main problems of practice throughout. And the first one back in February was really focused around student engagement. In March, we were working on sense making and non-routine problem solving with our 3-act tasks and things like that. Our last session was focused on getting kids to talk and kind of written and oral communication in math class. And this one, our final session, is actually going to be focused on kind of, okay, we've asked students to write or talk about math. What do we do with that work? And how do we help kids get better at communicating and being confident communicators in math? And kind of what do we do? We're going to share a protocol for looking at mathematical explanations that you had your students write. So as always, there's kind of these 3 goals. The first one is addressing a specific problem of practice, as I just mentioned. The second is we always like to let you experience these strategies as learners. We always use 8th grade content. And then really the most important and what has been so beautiful to see over these last couple sessions is just building a community amongst yourselves in LAUSD. There's been some great connections made between you guys, and it's just really fun to see you all collaborate as colleagues. So in that vein, we're going to do, as we always do at the start of the session, just give a little bit of space for you guys to share with each other. We're going to do our colleague check-in. So we're going to share a Jamboard in the chat. It's actually the same one that we used on Thursday, because we kind of wanted you to see what your other colleagues have tried out. But basically just maybe something you've tried, something that you're feeling good about, something that you're wondering about. If you have anything that you want to share, just go ahead when Jessica puts you in a breakout room, drop something onto that Jamboard. There's a list there of the activities that we did last session, the math picture talks, which one doesn't belong, Vanguard problems, MLR1, polygraph. So those might look familiar if you were here with our last session, but even if you tried, you'll see there's a 3 reads there. If you tried something from a previous session, we encourage you to just share and kind of have a moment to chat with your colleagues about that. So yeah. Jessica's going to push you into rooms of 3.
Oh yeah.
2. No.
I can do 3 actually. That works.
No, okay. Either way, just so you guys have a second to check in and connect.
Yeah, room 4, or sorry, excuse me, groups of 3. There are only 2 groups of 3, so if you want to just stay on the first slide of the Jamboard, that totally works. And let's do 8 minutes with a 1-minute countdown. So 9 minutes, we'll see you back.
Thanks so much for sharing with each other and kind of just checking in with each other about some stuff you might have tried. I love seeing one of the kind of common themes on Thursday as well was that they felt like students were kind of more engaged, which was so beautiful to see, because that was the number one problem of practice when we kind of moved to distance learning, was that how do we get kids to talk to each other or do anything or turn their cameras off? So I like to see that people tried some 3 reads, some which one doesn't belong, some picture talks. That's so cool. Would anyone like to unmute and share a little bit more about that? I see there's some stuff on the Jamboard, but if anyone wants to share, I just want to make a little space for that. Ooh, someone wants a review of the bond guard. We're happy to do that at the kind of planning period at the end of this session, if anyone wants to chat about bond guard.
I took your exact 3-read and did it with my students. So
Oh, really?
thank you for the template and everything.
Oh,
And
good.
they were very successful with the 3-read method, and it made the problem way easier than what was in the curriculum. So thank you.
Oh my
Right.
gosh, that's so great. I like got a little bit emotional right there. Oh, that makes me so happy. Anybody else like to share? Well, you're welcome to anytime drop anything in the chat. If there's something else that you tried in your class and you had a question about, we're happy to answer that at any time. So just a quick overview of our agenda for today. We're gonna do a quick little community building activity. We know you guys like to start with something that you can take and use with your students. And we have a super duper fun one to start with today. Then we're gonna kind of do a brief overview of that kind of like why we're asking kids to communicate in math that we did from session 3. I know there's a lot of people that are kind of newer. So we're gonna do just a quick little overview about those shifts, talk about the student work that we gathered from the little running laps performance, or not even performance, that's basically one question that we asked your students to write about. And then kind of talk about a protocol that we have for like identifying, what do we mean when we ask, what does a good mathematical explanation look like? And come to some agreements about what we want in a mathematical explanation when we ask kids to write. And then, as always, hopefully you will have a little bit of time at the end to plan on your own or with colleagues and have access to our resources that we have shared everything. For those of you who are new, I just wanted to mention at the end of the session, we always share the slide decks, all the links to everything. We have a shared resource doc that also has the previous 3 sessions. So no need to take notes or a screenshot. Unless you want to, you're welcome to, but you'll have access to all of this stuff. And just as a reminder, we are teachers. We know this has been a crazy year and we are here for you. Thank you for those of you who have joined us at office hours or have emailed us with questions. We know we cast like kind of a wide net and we share a lot of resources during these quick little workshops, and don't feel pressure to try everything. We love that you take something, whatever feels right that you want to try in your classroom. And so, yeah, we just wanted to reiterate that we're here for you if you need us, even beyond the scope of this project. Feel free to reach out, and you're amazing. If no one told you that today, great.
Ditto. All right, we're gonna do a really fun problem. This is always a huge crowd pleaser, not only for adults, but for students. We've done this problem with kids as young as 3rd grade, all the way through adults. So we really love to share this one as a type of problem where you can really kind of spark some curiosity and get kids excited about math. We've also done this sort of strategically towards the beginning of the year, although it does fit at any time, but to really send that message to kids that we value their problem solving and their thinking, and we want them to be creative and flexible in their thinking. We also like to highlight some alignment with some of the standards for mathematical practices. So we see this connecting nicely to the first SMP about persevering in problem solving. Also, constructing a viable argument, like convince me how you know that your solution is correct. But also in this particular problem, even evidence of the 7th mathematical practice, which is looking for and making use of structure. So as a tool, how are students able to use some of that mathematical structure to build towards a solution? So we're excited about this. I'm not sure how many of you have seen this problem before, but it comes from TED Ed, and they call them TED Ed riddles, but it's we call it the zombie problem, or like crossing the bridge problem. So I'm going to play this little video for you, and then we'll talk about next steps.
Taking that internship in a remote mountain lab might not have been the best idea. Pulling that lever with the skull symbol just to see what it did probably wasn't so smart either. But now is not the time for regrets, because you need to get away from these mutant zombies fast. With you are the janitor, the lab assistant, and the old professor. You've gotten a head start, but there's only one way to safety: across an old rope bridge spanning a massive gorge. You can dash across in a minute, while the lab assistant takes 2 minutes. The janitor is a bit slower and needs 5 minutes, and the professor takes a whole 10 minutes, holding onto the ropes every step of the way. By the professor's calculations, the zombies will catch up to you in just over 17 minutes. So you only have that much time to get everyone across and cut the ropes. Unfortunately, the bridge can only hold 2 people at a time. To make matters worse, it's so dark out that you can barely see, and the old lantern you grabbed on your way only illuminates a tiny area. Can you figure out a way to have everyone escape in time? Remember, no more than 2 people can cross the bridge together. Anyone crossing must either hold the lantern or stay right next to it, and any of you can safely wait in the dark on either side of the gorge. Most importantly, everyone must be safely across before the zombies arrive. Otherwise, the first zombie could step on the bridge while people are still on it. Finally, there are no tricks to use here. You can't swing across, use the bridge as a raft, or befriend the zombies.
All right. I'm curious if anybody has seen or done this problem before. Ooh, it's a new one. Oh, ooh, Jessica, you're nodding. Okay. Well, hopefully it's new for many of you. We do have a resource to share with you, which is a shared slide deck. And what you'll notice is that these little guys are movable. So if you want to sort of model like, okay, I'm gonna have, this person cross and then this person, whatever, right? Like you can move these guys around. And then we've also indicated a couple of the rules here just to clarify. So just to make sure everybody's on the same page. So there are no more than 2 people on the bridge at the same time. So you could have 1 or 2 people, but no more than that. If any 2 people are traveling together, their travel time will be the rate of the slower person. So if you and the janitor go together across, then it would take 5 minutes for you guys to travel across, even though you can make it in 1 minute. If someone is waiting on one side of the bridge, they can wait in the dark. But when anyone is traveling across the bridge, they have to have the lantern with them, whether it's like the one person, if you're traveling alone, you have to have the lantern, or if there are 2 people going across, you have to have the lantern with you.
And you have 17 minutes.
Oh, that's right.
To try to get across.
Yeah.
So what we're going to do is put you into breakout rooms. You can go to the slide that corresponds to your room and feel free to move those guys around and chat and try to figure this out. Who was it, Jessica, that knows this problem? You can be how you would be in the classroom, like maybe like a encouraging facilitator, and be curious about people's strategies so that you don't tell them the answer.
Well, different actually. It will be new actually.
Oh, great.
Okay.
There are a lot of versions of this, right? Like there's a fox and a goose and some straw or something, right? You can't have these together because this is going to eat this one. I don't know. So I've recreated the breakout rooms for 2 people per room. We're going to start with 5 minutes with a 1 minute countdown, and then we can check in to see how things are going. But good luck and have fun.
Darn. That wasn't enough time. I was right on the edge of something.
Oh, you're good. But you guys know how like when there's been like a really delicious meal served, you can tell that it's really yummy because nobody is talking. I know it's a really good problem because nobody came back into the main room early from their breakout room. They were like, no, you can't bring me back yet. So, okay. This is one modification. Obviously, like with a group of students in the person, you could be like popping around back and forth into groups. You could do that with the breakout room, but I was just going to bring you back to have kind of a collective conversation, and then I will put you back in your breakout rooms for another couple of minutes. I'm wondering if, I don't want to hear a solution yet, if anybody has one, but what is a strategy that you have tried that is maybe giving you a little bit of trouble, or you're like, I'm trying this and it doesn't seem to be working?
One thing that doesn't seem to be working is if everybody has to go all the way across before you come back. Which makes me think there's something like where you leave someone in the middle and go back, and then somebody else to walk the rest of the way with them.
Okay.
To double up on that time.
Okay. So the combinations that you're trying don't seem to be giving you enough time, right? You're going over 17 minutes for some reason. Okay. Yeah, because
just to clarify a rule, I just wanted to mention you can't leave anybody. You can leave them on either side of the bridge, but you can't leave them in the dark in the middle of the bridge.
Oh, I thought they could wait for somebody with the lamp to come back to them.
Only
on the side.
Only on the edges. Okay.
Well, because yeah. So I just wanted to clarify.
Got it.
Has anybody been trying to like have the, I guess in this case, this is you, the 1 minute person, like escort everybody across and then come back and then take another person and then come back? How's that working? No, some head shaking. Okay, it's not working. Okay. So, it's funny because in that method, like if I take the janitor across, how much time is that going to take me? Or how much time will that take us? 5 minutes. Okay, cool. And then like I come back and that's 6 minutes total. And then maybe I want to take the professor across, right? So now that's guaranteed to add another 10 minutes, right? So that's one, like a guarantee 15 of my 17 minutes. That's like a pretty big investment. So the one question that I'll pose before I put you back into your breakout rooms is there any way that you can be more efficient in getting the professor and the janitor across? Is there another strategy that you might use or another pairing that you might use to shorten the time needed? So I'm going to put you back in your rooms.
I have a question.
Yeah,
sorry. In the rules, you didn't say this, and I was just wondering from the beginning, can somebody carry someone?
Oh, you know what? That's a good, no, nobody states that explicitly, but I would say that does sort of fall into the category of more than 2 people being on the bridge at the same time, or even.
But that would cut the rate, because if I'm carrying the professor,
right,
and I'm the person walking, I could still make it in a minute and have plenty of time to go back and forth.
Michelle, I really like your creativity, but I'm going to say no.
I also really enjoyed the image of the professor on the piggyback ride. Just
yeah. Hop on, friend. Let's go.
Yeah, I will say there's no like tricky tricks. Like I know that a lot of riddles you have to like think about something that's like you wouldn't think of it. It's totally possible for them to all just walk and but I like your creativity.
All right.
So no throwing the lantern from one side to the other side.
Yeah, that's my question too, is about the lantern. Right, the lantern has to be traveling and it has to be on the bridge.
Yep.
People can't wait with a lantern on one side and somebody find their way in the dark.
Correct.
And there's only one lantern.
Correct.
Okay. All right.
Okay. I'm going to give you 4 more minutes. We'll be back.
Michelle, did you do it?
We discussed, like, I just don't know about the proximity of the lantern, but as soon as I start getting back on the bridge, if the lab tech could start walking towards me and we meet at the midpoint and come back, that would be 2 minutes, and then the same thing. But I just don't know about how close you have to be to that person with the lantern.
Yeah. You have to be holding their hand.
Oh, okay.
To be on the bridge.
Yeah. You have to be like in their little spotlight. But I love your continued Wait, where's Henry? Henry, did you get it? Oh, he's so close, you guys. He's so close. Did anyone get it? Oh,
let's see, Henry, please share.
Okay. Do you want the solution? Oh.
Bootsy's like, Danita, I can, they're like,
yes.
No.
Wait, I think I got it. Okay, I think I got it.
All right, let's see. Let me play along with you. Hold on. Let me pull up my little guys.
And just while Jessica's getting ready, I just want to highlight how beautiful this is as a kind of collaboration activity, because strategically we're asking you questions that are not giving it away, because that's not fun for anybody, but letting you struggle with it. And what's cool about this problem is the numbers are so easy. So it seems like this should be so easy, and then it seems impossible. And so our job is to kind of like push on that and let you cook. Okay, so Bootsy has been persevering. Let's hear it.
Okay, I think I got it.
All right, here we go. Let's try.
All right, the 1 and the 2 are gonna go.
Okay, so if 1 and 2 go together, how many minutes is that?
2 minutes.
2. Okay, next, what happens?
Okay, the 1 goes back.
So 3 minutes.
3 minutes. Now, the 5 and the 10 go.
Together?
Together.
Ooh. How long does that take?
That's 10 minutes.
So that's 13, right?
We're at 13. Now send the 2-minute guy back with the lamp.
So that's 15.
15. And then these 2 go across together.
But how can
Bootsy?
I just did it
how
too.
can
So the key here, right, is to send the 2 slowest together, even though like it initially, I think a lot of times we think like, oh, okay, I'll just take the 1 minute person and like they're the shuttle, you know, back and forth. But in that situation, then you have to have the 5-minute person go along or go, and then the 10-minute person go. And that's a total of 15 minutes. So a way to minimize the time that they need is to have them go together. That saves you actually 5 minutes in
You know, when Danita was the one who called that, she said, we can't send the 10-minute guy first. And then I said, oh, and then the 10 and the 5 have to go together to chop out 5 minutes. And then that's how the 2 of us got there.
I love it.
But
We were
I
both
have a
there.
question. I
We
have
were
a
both there.
question. If you set the 1 and the 2 cross, that's gonna take 2 minutes, and then 1's gonna go back.
3.
But then you said 5 and 10 are gonna go.
It's not gonna
That
work.
means it's gonna take 5 minutes to get back with the lantern.
Exactly.
no,
So it didn't work.
Philip, the 2-minute person is gonna run back. They're gonna hand them the lantern, and the assistant is gonna run back.
Yeah, the 5-minute person doesn't come back. The 2-minute person was over
Here, we
there.
can show you the little
Okay,
end
yeah,
of the video
okay.
that you can show.
So I thought I heard that a 5 and a 10 were gonna travel together. That means the 5 would have to go back.
But
if,
the 2
if
is
they are the first pair to go across, that is true. But in Bootsy's solution, she actually sent the 1 and 2 together first. And so then you have the 2-minute person hanging out on the other side.
and she can run back.
So I'm going to show you
Here, we'll show you.
the solution. Here we go.
At first, it might seem like no matter what you do, you're just a minute or 2 short of time. But there is a way. The key is to minimize the time wasted by the 2 slowest people by having them cross together. And because you'll need to make a couple of return trips with the lantern, you'll want to have the fastest people available to do so. So, you and the lab assistant quickly run across with the lantern, though you have to slow down a bit to match her pace. After 2 minutes, both of you are across, and you, as the quickest, run back with the lantern. Only 3 minutes have passed. So far, so good. Now comes the hard part. The professor and the janitor take the lantern and cross together. This takes them 10 minutes, since the janitor has to slow down for the old professor, who keeps muttering that he probably shouldn't have given the zombies night vision. By the time they're across, there are only 4 minutes left, and you're still stuck on the wrong side of the bridge. But remember, the lab assistant has been waiting on the other side, and she's the second fastest of the group. So she grabs the lantern from the professor and runs back across to you. Now, with only 2 minutes left, the two of you make the final crossing. As you step on the far side of the gorge, you cut the ropes and collapse the bridge behind you, just in the nick of time. Maybe next summer you'll just stick to the library.
Awesome. Well, you guys, thank you so much for playing along with us for that activity. Like we said, we've done this with students, we've done this with adults, and it is a huge crowd pleaser. And this is, Solana has been a rock star when we do this with students and teachers. She'll like cut out the little guys for teachers to like move back and forth. And so this was our digital version or digital solution to that. But it's nice to have like a little manipulative, especially if you're not sitting right next to somebody, you can sort of model that. So.
And we'll give you access to this deck if you want to make a copy of it and use it with your students. Thank you for participating. We know that was like a little bit of a annoying struggle for your Saturday morning, but we persevered and we got through. All right, so we just wanted to kind of just do a quick overview. We asked you guys to give your students a little performance task to gather some information about their, or just kind of give them a first chance at explaining something. And I just want to kind of go over again, like why we did that, because, we're asking students to explain. And one thing that we like to ask is, why do students think we ask them to explain? And just like, why do you think kids think that we ask them to show their work? Any guesses?
They think that we think they cheated.
Yeah. They think maybe to prove they're not cheating, we got to show our work. Or maybe to get a little bit of credit. Or maybe because teachers are super mean. Math teachers are mean. They're making me write. I have to write in all my other classes. But why do we ask students to explain truly? Like, what are we hoping to gain from hearing students explain their thinking? Anybody want to unmute?
Yeah, I agree with Jessica on the chat.
Oh, what'd she say? I'm sorry.
It's a way for
she's saying, yeah.
Yeah, we want to see what they're thinking, right? We're not doing it just to be mean and make them right. We want to understand their process and what they're doing. So there's a big disconnect there. And I think that it's important for us to highlight to students that not only is it for us to see what they're thinking, there's just, if we're preparing them for the world, to use mathematics in the world, there's just no job in the world where you get a math answer and you circle it and you hand it over. Like how they have traditionally done in math class, where you're just like, yep, the answer is 42, bye. Any Hitchhiker's Guide fans here? The 42 is the answer to everything in the universe. Okay, but really, if you're planning a wedding and you say this is how much it's going to cost, or you're building a house and you say this is how much it's going to cost, or you're planning a protest and you want to know how much paint to buy or how big to make this be, or you're a restaurateur and need to order food or figure out menu prices. There's just no job in the world where you just come up with an answer and you don't have to explain yourself. We went over this slide last time, but if you're new to this group, this is from the 70s. The top 3 skills for the Fortune 500 companies were writing, computation, and reading. But once we got even into the late 90s, communication and problem solving became so much more important. And I know that's a very old list, but in 2020, communication was the number one from every single large company. Being able to communicate was the top skill. And it's not just these massive companies. In customer service jobs, being able to communicate is like the number one thing that we're looking for working with people for any kind of job. So if that's true, and we are truly trying to prepare students for this world, how do we help them get better at that? And that is something that we have been focused on the last few years, is really giving students opportunities to build this muscle of communication. And if you were at session 3, one of the ways is give them lots of opportunities to practice. Which one doesn't belong? Notice and wonder, 3 acts, Bongard, number talks. give them opportunities to orally practice communicating in math class and make that normal, and give, get, practice making arguments, practice challenging each other. And then also give them opportunities to practice writing a mathematical explanation, which is what we tried to do with that little tiny performance task that we sent out running laps, which you'll see at the bottom. They're not going to just naturally be good at writing a math explanation because they've never been asked to before. So opportunities to practice is the number one. Number two, ask them questions that are worth explaining. For example, this question is not worth showing my thinking. So just take a look at it for a second. Here's a little girl. She's thinking, and then she's got it. But if you look at that math problem, there's nothing to even show. There's not, why would we, there's not even carry, there's nothing to do. So because of that, she showed herself, I don't know the answer, now I do, and then also a bunny for you. I don't know why, flying bunny. But that question's not worth explaining or showing anything because it's just a number sentence. So also, if you weren't with us for our last time, we want to have better explanations than this guy. And if you haven't seen him explain how to identify an aspen tree, I'm going to show you. But basically, this idea of maybe your first explanation isn't great, and how can we build on it and revise it to make it stronger? But I'll just let you know, I'll let you see his first try at explaining to us how to identify this tree. If you haven't seen it.
Wow, score! Look at this. This is an aspen. You can tell that it's an aspen tree because of the way it is. Wow.
Cool. Thank you, sir, for that beautiful explanation. But that's what, students do that when you first ask them to like, how did you get that? And they're like, oh, I did the math. It's like, okay, can you say a little bit more? What do you do? Kind of honoring that maybe their first try is not going to be be the best, which is why we've built this session around, okay, students have written something or said something. How can we give them feedback? How can we help make their explanations better? And that's this section on re-engagement and using the student work that you gave your students. Jessica's going to take us through that right now.
Yeah, so I'm actually thinking, because we spent a good amount of time on the zombie problem, which was completely warranted, do not get me wrong. I'm thinking that maybe we should do our little stretch break right now, since it's almost 10. And so let's take 5 minutes. We'll come back at 10:03 and we'll see you then. Go refill your coffee, use the restroom, whatever you need. We'll see you back at 10:03. All right, so in this next portion, as Solana mentioned, we're going to talk a little bit about how to give students an experience to clarify what it is that we expect when we ask them to write a mathematical explanation. We believe that students get better at mathematical writing through practice, but also through guided practice, not just saying like, write more, keep writing, but giving them some targeted and specific feedback. And even as a teacher, when I started doing this kind of work with my own students, their writing consisted of like, first I did this, then I did this, then I did this, which wasn't necessarily a bad thing, but I was looking for something that was a little bit more like, convince me that this is true. And even just having my students document their step-by-step procedures, I didn't know how to like push them to, okay, but convince me, which I think is a different type of writing. So I'm sure that many of you have experienced when you give your students some sort of an assessment, they fall all over the board, right? You might have some students that just were not demonstrating success, but then you also have on the other side of the spectrum, students that aced it. So, traditionally as teachers, we pick one of these 3 options. First, let's go back and reteach the topic with the entire class, right? We've got to go back, start all over. And think about who benefits and who would sort of not benefit from that option. If I got it that first time, I'm going to be so bored if we have to go back and do it again. Another option would be, let's identify some students that need some remediation and look for some opportunities to reteach or, give them some additional support. Oftentimes that could result in like an additional math class or doing math outside of the traditional period, which, if students aren't really fans of math, you know what they love? Doing math on their free time as like what feels like a punishment, right? I mean, oh man, I have to come in and give up my lunch break, or I have to give up an elective period. Like it's not super fun for kiddos. Or feeling the pressure of the overpacked curriculum, the teacher just decides to move on to the next topic because sorry, like we don't have time to go back. And this is a reality, right? Our curriculum is so overpacked, especially in distance learning where we've, have even fewer minutes or even fewer face-to-face opportunities with kids. So again, think about who might benefit and who might not benefit from a situation like that. And you know what? There's got to be a better way. There just has to be. And that's what we call a re-engagement lesson or activity. So in a re-engagement lesson, we're going to make use of actual student work, which might include some unique thinking or misconceptions, or even some innovative strategies. It has all students rework a task, but in this case, from a different perspective. So I wouldn't just ask students to do the running laps task again without any sort of directive. You'll notice that you are going to engage in this running laps task, but from a different perspective. We may confront a misconception so that we can just deal with it and let it go and move on. We may, in this case, based on the design, this could actually give some students a strategy for solving the problem that didn't have one initially. Or it might help students that had an initial strategy and felt really confident. It could help them solidify or make some connections, or even just clarify the thinking of their peers. In cases where I did this with my own students, I would have my, one of my top students look at somebody else's work and be like, whoa, this kid's a genius. And it's like, wow, how cool that that kid who totally got it the first time was still able to have some benefit from this type of lesson, as well as my students who weren't successful the first time feel and build some of that confidence, like, okay, I know what to do now. I'm going to give you a moment to just read these bullets. They do correspond. So on the left-hand side, these, I would say, describe the reteaching strategy, versus the right would be the re-engagement version. So in reteaching, we would teach the unit again, or in re-engagement, we're going to revisit students' thinking. So I'll just give you a moment to read those correspondences and differences. I'm wondering if any of them jump out at you, or that kind of like, oh, that's interesting. I hadn't thought of that before. Do any stand out to you for some reason?
If I may.
Please.
I really like the one that says the whole class is engaged, because yes, we tend to try to help the ones that are, let's say, underachievers, but the ones that are on task, we still need to somehow give them guidance to advance from where they are. So that I like that the whole class is engaged.
Thank you so much. Awesome. So hopefully you're going to see this come to life, and think about reteaching versus re-engagement in a new way. So we're going to try one, and I'd like to also connect this to one of the math language routines called Clarify, Critique, Correct. So it's kind of a version of this where we're going to be looking at some student work to give feedback, highlight some of the things that we think are great about it. So let's jump in. The structure that we're going to use is we're going to revisit this original question about running laps, and you're going to read 3 pieces of student work. You're going to think about what is clear and correct about each piece of student writing, and then you're also going to think about what feedback you might give to each piece of student writing. You're going to work in groups of 3 in a Jamboard to think about what's clear and correct, and then what feedback, and then we'll have a whole group discussion. So this original task was called running laps, and you have some information, but essentially the question was, who ran faster, Jack or Remy? And then we asked students to explain how they figured it out. So don't worry if you were not able to give this to your students, we're going to get you caught up here. And if you were not in a previous session, don't worry, we're going to get you caught up as well. So I've purposefully covered these numbers so that we can make sure that we're all kind of on the same page and starting from the same place. So 2 students, Jack and Remy, were running laps around a track. They ran at constant speeds. Jack ran some number of laps in some amount of time. Remy ran some number of laps in some amount of time. So the question is, who ran faster, Jack or Remy? And I want you to just take a moment and think about how you would solve this problem. How would you use the values to determine who ran faster? Would anybody like to unmute and share? I know I haven't given you the values, that was on purpose, but how would you use the values to figure out who ran faster?
I would probably use division to find the constant rate for each person.
Okay. And Danita, what do you mean by constant rate?
Well, it says they ran at a constant speed, so I'm like, they must have been running the same throughout the whole time they were running the track. So
okay, so whatever speed Jack was running, he kept that pace the whole time. Whatever speed Remy was running, she kept that speed the whole time. Okay.
Yeah.
I also connected it to proportional relationships.
Okay. And I'm wondering if that also connects to what Bootsy dropped into the chat to find some sort of a unit rate. So like how long does it take each person to run one lap? So in this case, our unit is like speed per one lap. Okay, cool. Awesome. So notice by covering up the values, I've sort of like a 3-read strategy. I've hit pause to like say, let's make sure we understand how these quantities kind of connect and how we can use them to work towards a solution. That's how I'm sort of giving access to all my students, because odds are that they haven't remembered what the values are. Now, the second question here is explain how you figured it out. And so that's what we're going to be looking at. And I want you to think about like what elements would you include in an explanation if you were to convince somebody that either Jack ran faster or Remy ran faster. So here's the big reveal. So they're running these laps, they're running at a constant rates, excuse me. Jack ran 2 laps in 6 minutes, 10 seconds. Remy ran 3 laps in 9 minutes, 6 seconds. So I'll give you a moment just to kind of digest that and think about who ran faster. So who do we think ran faster, Jack or Remy? Remy, okay. I've got 1 vote for Remy. Do we agree that Remy was the faster runner in this case? I see Chrissy nodding, okay. Solana agrees. All right. So the cool thing about this is that okay, great, thank you, Danita. There is not only one way to convince somebody that Remy is the faster runner. You have a lot of flexibility here. You can use this information. It was proposed that we find a unit rate, but that's not the only way that you can use to solve it. So I'd like to just remind us, thank you, Jessica, of our structure here. So you're going to be reading 3 pieces of student work, and you're going to be wondering what is clear and correct about each piece of student work. And then you're also going to be thinking about, if I were to give this student some feedback around how to make their explanation more clear, what kind of feedback would I give them? So here's our first piece of student work. This comes from Alice. Alice said, Remy ran the fastest. It took 3 minutes and 2 seconds to complete each lap faster. So in your breakout room of 3 people, you're going to think about what is clear and correct about Alice's thinking, and what kind of feedback would you give Alice to make her explanation even better. Bianca said, for Jack, I divided by 2, and Remy's I divided by 3. So again, you're going to be thinking about what is clear and correct about Bianca's explanation, and then also what kind of feedback you might want to give Bianca. And lastly, we have Charlie, who said, I figured it out because Jack did less time than Remy, which means he did it quicker. So you're going to ask yourself and talk as a group, what do we think is clear and correct about Charlie's thinking, and what kind of feedback could we give Charlie to help make his explanation even better? So we're going to do this in a Jamboard, and it's going to look like this. I'm going to skip ahead just one here, but you're going to have, you'll notice in the top left-hand corner, here's the original prompt. You have the piece of student work for Alice, and then the next one is for Bianca, and then the next one is for Charlie. And what I'd like you to do is, using a yellow sticky, make a comment or leave anything that you'd like to share with Alice, Bianca, or Charlie that you think is clear and correct about their explanation. And then using a green sticky, think about what kind of feedback could you give Alice, Bianca, Charlie. Does that make sense so far? I hope. Okay, I'm seeing some nods, that's good. I also want to make sure that you guys understand my expectations when I say that I want you to tell each student what is clear and correct. So in the Jamboard, you'll actually see on slide 1, here are some sentence frames that you can reference if you wish. So when you said this, it made sense to me. I agree with you when you said this. Because you said this, I was able to understand your thinking better. Give them those kudos. Let them know what helped you better understand their explanation. But also I want to highlight what I mean by giving feedback. So obviously we can be mean when we give feedback, but just because we're giving feedback doesn't mean that we're being mean. So I want to make sure that you are kind and that you talk about ideas and not the people. So you're not gonna, bag on Alice or Bianca or Charlie, but you're gonna think about how can you just talk about their explanation in a way that could make them better. I want you to be specific and avoid opinions. And like I said, giving and receiving feedback, that doesn't mean that we're being mean, but also I want to make sure that we understand that it's going to help all of us with our writing to be better and to be more clear. So here are some suggestions. I understand this part of your explanation, but I have a question about this part. Or can you please explain what you mean by this? Or where did you get this number or this idea? Notice that I'm posing questions. I'm staying curious. I'm asking, can you help me better understand this? And if you said this, I would understand this part better. So are there any questions right now about your task? Solana has just dropped the Jamboard into the chat. Thank you. So on slide 1, you'll find those sentence frames if you wish for both what's clear and correct and then also what's giving feedback. And then if you click through, there's Alice's, there's Bianca's, and there's Charlie's, okay? We only have 3 groups. So if you wish to just stay on this set, I think that that would be totally fine. Don't feel like you have to keep going into the evens and odds and things like that. So if you just want to land on those first 4 slides, that would be great. I'm going to say that we could probably do this for like 2 minutes per student. So try to keep that pace of 2 minutes per kiddo. So I'll give you 6 minutes with a 1-minute countdown. So we'll see you back here in 7 minutes. Hi guys, welcome back. I know that that was probably not nearly enough time, but hopefully you got to at least start to talk about what are some of the things that we appreciate or value in a mathematical explanation. I'm just looking, I think 1, 2, 3, 4, 5, 6, 7. Okay, I think we're back. So would anybody like to share some of the things that they talked about related to Alice's thinking? What did you find that was correct and clear about, Alice's thinking? Remy ran the fastest. It took 3 minutes and 2 seconds to complete each lap faster. So it looks like we agree with their calculations. So correct calculations for 1 lap. Anything else that you'd like to highlight? Or even share some feedback?
It's also correct that Remy is the fastest.
Okay.
Faster than the
Jack.
other friend.
Perfect. Thanks, Colleen. What about any feedback that you might give Alice? What would make Alice's explanation even more convincing? Let's see. How do you know that Remy?
Me, yeah, I was gonna say for me, it would make it more clear if she compared the two to really show that Remy did run the fastest.
Thanks, Danita. Yeah, I think that it would be even better if Alice sort of drew that final comparison. Like, she's correct that that is the pace that Remy was running, but how do we know that that's faster than Jack? If you did get a chance, what about Bianca? So Bianca said, for Jack, I divided by 2, and Remy's I divided by 3. Did that calculation seem familiar to maybe your solution path? Okay, I see a few of you nodded. So, and actually, I think Danita had said in her first explanation of how she would calculate, she said, I would divide, right? So division could lead to calculating unit rate. What about kind of like feedback? What could we ask Bianca, or what could we say to Bianca to just kind of help move her explanation along? Go ahead, Colleen.
We could ask her what her results were after she did the division, just to keep moving her forward.
Awesome. Yeah. So like, great, you divided. What did that tell you, right? Or what did that number mean in the context? So yeah, I think that this sort of demonstrates Bianca knew sort of what to do with the numbers, or she could have just guessed a random operation and like, hey, good job, it worked out. But we don't know that for sure. For, excuse me, for Charlie, I'm wondering, what did Charlie do here? I figured it out because Jack did less time than Remy, which means he did it quicker. What do you think is correct about Charlie's thinking?
That the right runner is the fastest, but he has no evidence.
Okay, so Jack did take less time. And then can you provide evidence? Now, I think that Charlie had a slight misconception, or maybe misunderstood the situation slightly. Did anybody get to talk about that, or do you have ideas about that? Colleen, what did your group talk about?
Our group talked about the fact that Charlie is looking at the total time. In fact, Jack did take less time in total, and that's true. That is correct. It's just a question of whether we're interested in the total time or we're interested in the rate per lap.
So I would maybe ask Charlie, like, what does each person's time represent? Because you're right. I mean, and this actually came up a lot with this student work that we looked at. was that a lot of students did see, well, of course, Jack is faster because he took less time, but they weren't making the connection between how far did each person run, right? So like they weren't necessarily thinking about, what can I find that's common, like a unit rate, or, how do I make a comparison in this case? So they were just comparing one component to draw their conclusion. So awesome. I think that you guys definitely picked up on the features that we were hoping that you would. We were very strategic in selecting Alice's, Bianca's, and Charlie's work samples because we felt like they did kind of highlight some of the key things that we would be looking for in a mathematical explanation. So in general, when we talk about writing a mathematical explanation, it's really important that we include our mathematical thinking. So if you think about what Alice wrote, let me click over here. Alice shared her mathematical thinking, but only about one of the runners. Bianca did share her mathematical thinking, but didn't really put it into a context, which is like the next thing that we can say. We really like to connect our ideas back to the original problem or story. So for Bianca, she's explaining her mathematical thinking like, this is what I did, these are the steps that I took, but it's unclear why. And it's also unclear like, what does that result tell us? And then we also really appreciate when students can write clearly and connect our ideas together. So thinking about like for Alice's explanation, she did state Remy's pace, but didn't connect it to Jack's pace to really solidify her explanation. So these are the three components that we appreciate about a mathematical explanation, which Solana is going to get into a little bit more in a moment. But I just wanted to highlight and celebrate the different ways that you guys thought about this. And I mean that like by your students. We saw a lot of students that calculated a unit rate. So here's an example. Remy ran faster because if you divide 9 by 3, it equals 3. When you divide 6 seconds by 3, it equals 2 seconds. All in total 3 minutes and 2 seconds, which means Jack ran 3 minutes and 5 seconds. So pretty kind of straightforward, not a perfect explanation, but definitely demonstrating the approach that we can use a unit rate. We also had a student who saw that Remy ran 3 laps and Jack ran 2 laps. So what if I added 1 more lap to Jack's time? If Jack ran 3 laps, it would take him 9 minutes and 15 seconds. Remy did 3 minutes and 9 seconds, 3 laps in 9 minutes and 6 seconds. So Remy would be faster. So that was actually a different way of thinking. Another solution that we saw was students that scaled up. So if I have that Jack ran 2 laps and Remy ran 3 laps, what if I compared their total times for running 6 laps each? So notice that again, that's another way of thinking. So this is what we really love about these types of questions as well, is even though all of these students may have landed on Remy is the faster runner, by asking them to explain, we can see that there were multiple ways of thinking and celebrating like, awesome job, guys. Now, do we see any connections between these ways of thinking? And lastly, just in terms of if we're seeing that,
Jessica,
yeah, please.
I have a question.
Yes,
Or a
please.
couple of questions. All the things you said make sense, but my wondering all along are the following. One, at what point do we formalize the mathematics, the formalization of mathematical thinking? And also the second question, which standard does this address if we brought it back home?
Great question. So what do you mean by formalizing the mathematics?
For example, when you look at Remy's explanation, Remy ran not Remy, Alice. Remy ran the faster, it took 3 minutes and 2 seconds. And then compare that to Bianca. For Jack, I divided by 2, and Remy, I divided by 3. Now, so how do we calibrate the mathematics to ensure that they are leading to the correct mathematics, not just saying things? And then we justify that because they made an explanation. So that's what I mean by formalization, because we know when you calculate rate in this instance, we're talking about distance, time, which is speed, and which could lead them later on in science to velocity. So when we say, okay, are we dividing time by distance? Is that correct? That's the formalization that I'm.
Great. No, I appreciate that. And I don't know exactly at what grade level students are introduced to like distance equals rate times time, but that is definitely something that we could connect this back to. And also, I agree with you, Philip. I mean, we sort of give Bianca the benefit of the doubt because we know that a division in this case would lead to a unit rate, but like, just because she picked division, does that mean that she really understands the mathematics of her operation, right? So I think that the way that I might do that is, remember in the previous slides where I had the values covered up and we sort of talked about like, how could you solve this? That could be an opportunity to kind of pause and say like, well, why would we divide, right? Danita, her instinct was like, I would divide. And I think you would definitely have students in your class, I would divide. And then pausing and sort of taking the opportunity to say like, well, why would division be useful? How does that connect to the structure of the mathematics of the situation, right? Like, remember, we're talking about rates, we're talking about distances, times, things like that. So I think that that would definitely be an opportunity to solidify. And then in response to your second question, admittedly, this may not be a solid 8th grade content standard, but we actually like to, especially when you're first getting students to practice their mathematical writing, we want that content to be familiar and comfortable because we don't want to sort of compromise the opportunity to focus on the written component. And I'll give you an example. So Smarter Balanced actually calls this securely held content. So you'll probably remember that your students for Smarter Balanced take 2 components of the assessment. There's the computer adaptive portion and the performance task portion. The computer adaptive portion is 8th grade content standards, right? The computer adaptive component is like, okay, where is this student like in terms of their grade level proficiency? The performance task actually does not include any 8th grade mathematical content because it's looking to measure problem solving, writing, and their students' ability to model with mathematics. Smarter Balance learned a very harsh lesson actually when they wrote a performance task for 8th graders, and they included an item on the Pythagorean theorem. What they discovered is that many times in curriculums, geometry is pushed to the very end of the year. So 8th grade students who were sitting for this assessment had never seen the Pythagorean theorem before. And perhaps it was an item that was like, explain your thinking. And these students didn't stand a chance because they had never seen the Pythagorean theorem before. So now all of a sudden we have not collected any information about the student's ability to write because the mathematics was getting in the way. And so I know that's kind of a long-winded answer, Philip, but I think that we can balance like grade level content or, below grade level content with that, okay, let's focus on the writing, let's get our feet wet, let's, build some understanding, and then ramp up the grade level content piece. But also we have lots of things that we've shared that are squarely in 8th grade content where we do ask students to explain, just maybe not super formal like this. Does that answer your question? Like I said, that was really long.
Yeah, it makes sense. I don't want to belabor this, but one can still find something around 8th grade content to arrive at the same thing. That is where I'm going.
Yes. I mean, there's certainly connection to, linear equations and functions, things like that, 100%. Cool. Well, awesome. I mean, your students really impressed us with their writing. If it is something that you are interested in, hey, can I get my student responses? Just send us a little email. The form, because we didn't include like a drop down of teacher names, it just would take a little bit of time to filter out, but we're happy to do that for you. So just let us know. Want to just check in. What did you think about this kind of re-engagement lesson? How do you see this working with kids? What questions might you have? What do you see that's possible, and where are you excited to kind of take this? And then how can this activity or something like it help your students with their writing?
If I may, I feel like when they do writing, we give them also an opportunity to use the math language, academic content, because we don't normally do that on an everyday basis, or at least the students, right? It's not that they're talking to mathematicians at home. So that is one way to give them opportunity to practice the math language.
Absolutely. Thank you so much. Anything else you'd like to share as sort of a reflection or feedback? Well, we're going to move on to the last component here, and I'm going to turn it over to Solana to talk to us about we're calling an MCL framework.
Thanks, Jessica. So one thing that we as teachers, when we started having students explain their thinking, we started seeing trends among the different types of explanations, and we kind of naturally started coming up with some components that we think of, like what makes a math explanation strong and clear. And what this MCL, and I'll explain what that means, is kind of a useful way to look at student mathematical explanations. And you'll see that a lot of the things that you guys had as feedback for the students that we just looked at, those are the parts of it. How can we honor, what students have written and give them some feedback that will be useful for us instructionally as teachers, and useful for students to get better at explaining their thinking. So basically, the reason that this came about was we've been working, as Jessica said, with Smarter Balance, and we were noticing that, like, giving a number score to a piece of mathematical writing isn't very useful, because if you get a 2 out of 3 and you're one of those students like Alice and Bianca, what piece is missing? They're missing different pieces. They both got the answer right, so we have some evidence of understanding, but they're both missing something about their explanation, and it's a different something. So how can we, if we're looking at explanations, how can we have some indicators that really highlight what is there in their explanation and help provide some feedback to strengthen those explanations? So we've boiled it down to kind of and this is kind of a working model, but this has been really useful for us when we start looking at student writing. The M stands for, did the students mathematize the situation? It is, are they setting up the mathematics correctly? Did they divide and find a unit rate, or scale up to find a unit rate? The second piece is, did they connect it to the story? We don't just want a bunch of numbers, because that's great, you did the math, but if we're looking at an explanation, did you connect it back to the problem? What do those numbers mean? Dividing by 2 and dividing by 3, that's the right math to do. Why did you do that? What do you talk, and this is the big difference between evidence of understanding and writing an explanation, because I know that Bianca divided by 2 and 3 for a reason. I know she understands something, but she hasn't explained it. So it's really hard as teachers to, like, not be like, give them the benefit of the doubt and be like, I know what she meant by divided by 2 and by 3, but that doesn't push that student to explain it better. And the third piece, the L, is basically do they make a logically complete sentence? Like, is the explanation clear? Does it all connect? Do they make a claim and, like, have a conclusion? So those are the 3 pieces of the MCL. And I'm going to give you a little bit of examples, and then I'm going to actually give you guys an experience where you get to calibrate around some student work similar to how you would do an ELA. Like, let's come to some agreements about writing a math explanation. If we say that to write a strong explanation, you need to include your mathematics, you need to provide a context, connect to the story, talk about what the problem is, and make a complete thought, like write a logically complete thought or statement. Those are the pieces that we're looking for. This is kind of a back end flow of how we look at these explanations. The first one is, do they even make a mathematical attempt? If your student writes IDK, then there's no point in looking at this explanation. But do they try something? And then do we have evidence of each of these pieces? And these can be in combination or by themselves. Is the math there? Do they connect to the context? Is it logically complete thought? Then you would get all three, an MCL. Maybe you just will have the M, maybe you'll have an MC. If they give it a shot and don't have any of those, they would get what is called an NE, which just means there's no evidence. And it doesn't mean that they don't get it. It just means in this instance, we don't have evidence of these three components. So here's a quick example. When you're looking at these pieces of student work, think about if you were sitting next to that student. If they read this to you, what would your true teacher heart, what would you ask them? What would you say to them if they were sitting in front of you? For example, a lot of students just will write numbers, and that's great because we know, these are all from your students, by the way, this is the right math. Dividing by 2, dividing by 3, comparing the times. These are all great numbers, but if I was sitting with these students, I would just say, why did you do this math? The feedback would be like, what are these numbers? What did you divide? Why are you finding a unit rate? What are you talking about? 610 divided by 2 is 305. That is the right math, but why did you do that? What are those numbers stand for in this context? So think about that feedback, and that is the part where, okay, we've got the math. We need a little bit of more. Add some units, add some words. Oftentimes students will leave the numbers out entirely. So think about what the feedback would be there. And this is great. Remy's faster because I figured out she could run the laps in less time. Okay, great. Show me, what math did you do? How did you figure it out? Can you back that up with some numbers? So in this case, add some math, add some numbers to your explanation. Or students might kind of they mathematize it, they add some context, but they don't wrap it up. That feeling that Danita called out in Alice's work where, I figured out that here's an example with Jack. I divided the time by the number of laps it takes, and Jack's 3:05 to do 1, so he loses. Is the math there? Yeah. Is the context there? Are we talking about running and Jack and laps? Yeah. But that feeling that you had with Alice's work, like, what about the other person? Compare it to something, like, wrap it up. Let's have a conclusion. That's missing that like logical completeness to convince us that Jack is slower or Remy is faster. And then also some students might write like incredible things that blow your mind. I don't know if Miss Garcia is in this meeting right now, but Eduardo wrote, I first needed to find the constant rate for each runner. I did this by dividing the time they ran by the number of laps they completed, giving me 3 minutes, 5 seconds for Jack, 3 minutes, 2 per Remy. As you can see, Remy ran slightly faster than Jack by 3 seconds per lap. So this student had it all. It's not necessarily you have to write a lot to get all three, but this student clearly has had experience and practice explaining their thinking, because you'll notice all of the pieces are there. The math's there, the context is there, and they wrap it up with an, as you can see, it's so beautiful. So if Mrs. Garcia, I haven't looked at all of your last names. I meant to look for you to see if you're here. You're here. Oh my gosh. Yes, Nanette, that is so awesome. Give Eduardo a virtual high five.
I will, thank you.
So basically,
I got emotional.
Oh, good. I'm so glad
this is a special ed student.
Oh my gosh. And this is one of the things, like, we love calling out and showing these pieces of real student work, because the kids will teach us so much stuff. And Danita called it out too, like, you learn from them. Wow. Showing students another student's piece of work and being like, oh, that's what is expected in a write. Okay, I can add some numbers. I can add some context. I love how clear Eduardo's explanation is. I can do that when I write. Next time, I'm going to make sure I add some things like that. Jessica's crying over there. You're sure you're crying too. Okay,
yeah.
Wipe your eyes. So we're gonna, that's so beautiful. That makes me so happy. And I think that's why this kind of honoring what students are bringing to the table and giving feedback to help make them stronger, it's just going to make everybody more confident at communicating their thinking, and it really shows them that we honor that process. So what I want to do now is give you a little bit of time just to come to some common agreements. I'm going to give you just a few pieces of student work around running laps. We've kind of used it a little bit. You've seen some things. Here are the kind of rationales in terms of the MCL for what we looked for when we scored these or analyzed these pieces of student work. You know, do they find a unit rate or a similar approach? Jessica shared a couple different ones. Do they scale up, scale down, add a lap, subtract a lap? Do they talk about the context? Is it a complete thought? Like, do you feel satisfied? Like, okay, I see your whole thinking here. And what I'm going to have you do is I'm just going to show you the student work in this whole group, just a few pieces of work, and you're just going to score it on your own. So you're just going to jot down or just remember, like, is that an M? Is there math? Is there context? Is there logic? Is there math? So you're going to have a second to score it on your own. Then I'm going to put you in a breakout room, and you're going to have a Jamboard. Whoopsies. I was making sure you were able to edit it. A Jamboard like this, where you're going to chat with a partner and just drop a score into one of these columns. Like, okay, we think this was a certain, score. And these scores are not hard and fast. What this is meant to do is, if we're going to ask students to write, and we've come to these agreements about what components we want, do we agree on what that looks like in practice, in what students actually write? So you can discuss, you don't have to come to an agreement, but kind of convince each other, push on each other. If you're like, there's no math here, yes, there is, duke it out. And then write a sticky note in the column to convince your students. So I just want to give you 2 minutes to just look at this, look at these pieces of student work, go through that MCL in your head, and you can just jot them down. I'll be quiet, and then we'll push you into some rooms to talk to someone about it.
Is it 1, 2, 3, 4, the scores? Or?
So, and I did put descriptions of each of the categories in the chat, but basically what you would think about putting in that final column is like an M or a C or an MC or an NE, so it's not numeric.
In the interest of time, I'm just going to pause right there and let you go chat about these with your colleagues. Again, with the reminder that there's no correct answer. Really, I have an idea of what I would give these responses, but really this is for us to build some community agreements about what we see in these responses here. So I dropped a Jamboard in the chat. What you're going to do is just go in there, chat with your partner, come up with something. Maybe you can write it in, you can text box it in, you can sticky note it in, and we'll come back together and share in a few minutes.
5 total?
Yeah. I mean, I don't know what time is, maybe 4 minutes.
All right. 3 minutes with a 1 minute countdown.
And don't worry if you don't do them all. We just wanted to give you a little bit of the flavor of this. Ooh, this is interesting. Did you click to see your colleagues' Jamboards? There's some disagreements, which I love. That's the whole idea here. So what I wanted to just do is take a second just to kind of, is there any one in particular that you feel like pretty solid, that you have anything to share? Anybody? Because if not, I'm going to push on some of the ones that had disagreements. What do we think about student A? Is the math there?
Yes.
Yeah. So we got an M, and I saw a lot of M's in the Jamboard. Is there any context? No. I mean, the letters match their names, but that's not really enough for an explanation. And do we feel like they've come to a conclusion in any way? I feel like some people have said that, like, they think that final comparison maybe looks like something, but this is a perfect example of something that I would say, all of this math is right. You clearly mathematize the situation. Can you tell me what these numbers are? And can you tell me what your decision is? Who ran faster? What did you want to do with this information?
And one thing that I would add too is I think that this is where one reason that we see this as a common type of explanation is, think about, this is kind of like, first I did this, then I did this, then I did this, which I think when students start to do mathematical writing, this is what they think you are looking for as the teacher. just like a list of steps, right? So that's what we're kind of pushing on.
And it's great because we can honor that and be like, this is beautiful. This is all the right math. Can you give this a little bit of context or connect it or make it, you know, kind of conclusion? How about, I see that a lot of people said MC for this second one. I would agree with that. There's the M, there's the context, and then there's the kind of like, but what about Jack? That feeling that you get, what about Jack, is like that we have not concluded anything. We just said a true thing that is connected to the context and is the right math, but like, so what? Yeah, Colleen.
I want to take us back, if it's okay, just for 1 second to student A, which is, I was just thinking as a teacher, grading, let's say you're grading that on a test. It would be so easy for a teacher to give that student 100% because I could see a justification for she gets it, right?
Mm-hmm.
Like she gets what's happening. I could also see a teacher who's really quantifying this idea of an MCL to say, you got an M, but you didn't get C and you didn't get L. So that's 1 out of 3 and that's 30%. And so you get an F. Mm-hmm. And so my point is that it can really go in so many different directions what the grade is. And I feel like how I felt when I was a student in school, I felt like my English essays were so subjective. Like I could think it was a great paper and my teacher could give me a C, or I could think it was awful and my teacher could give me an A. And I always felt like in math, it was very cut and dry. Like I either got the answer right or wrong. And I feel like right now we're really emphasizing for students that we want your thinking and we want to see your explanation. We want to understand. And what I love about the MCL is that it takes us out of that quantitative, it's 100% or it's a 30% or it's a whatever. And it's like, look, I really stand by my word when I say I'm not looking for just like check. It's not a checklist, you know, I'm actually trying to give you the tools to have a complete package. Sorry, that took a long time, but it's so great.
Absolutely. And I think that's the idea, is that this is not a high stakes, this is not a grade. This is meant to be an exercise of like feedback and revision. Like take that, go add some stuff, and now, wow, look how good this explanation is. And I want to just, in the minute that we have left, talk about student E, because if I look through the Jamboard, I saw everything from no evidence to an MC. So I just want to look at this one really quick. Remy was faster because she ran 3 laps, and that's more than Jack. Is that the correct math? Did they mathematize it? Are they setting up the model correctly to compare to rates? They're not, right? It's kind of that thing that Charlie did where they're misunderstanding the amount of laps being that she's faster while not taking into consideration the time. So, but are they talking about Remy and running laps? Do we have some context there? I see that there's a little bit of context there. They're not just saying because I'm smart or whatever, which is what, if we say no evidence, we kind of reserve that for someone that's just like maybe something like D, like I divided, which could be like, great. I need a little bit more than that. So I think that why this is powerful is that if we as teachers engage in this kind of work to help us think about what we're looking for, then we can share with students, hey, when you write something, I better see some math, I better see some words and context, and I better feel like I can understand your whole explanation. So Jessica will click forward to show what I would have given those ones. But by all means, I think the practice of talking to each other about it is the only way that we can kind of build that capacity as a network of teachers of like, hey, if we're going to ask our kids to write, which takes time, and it takes time to look at because you can't just score it like in a computer, let's make it worthwhile and have it be this kind of asset based, like, I see that you brought these things, here's some feedback, and like, let's give you another try to revise. So if you have strong feelings about any of those, oh, okay, Danita said that if they got the math wrong, it was automatically an any. Yeah, you can give any letter or combination of letters, except an L by itself doesn't really exist, because just saying something logically complete doesn't necessarily mean you answered the question. So usually there's at least a little bit of something. But if they they miscalculated or something and still said that Remy was faster because I compared the rates or whatever, they could get a CL. I don't know. This is just the first dip into this conversation. We love talking to teachers about this and would love to hear your feedback about it. If you have any kind of feelings about how this could be useful in your PLCs or in your practice or for your students, this is like something that we're very passionate about, is giving kids opportunities to write and opportunities to revise, so that they are able to be those competent and confident communicators. I didn't mean for that to be so alliterative, but this is how they get better at it. And so that's what I want to end on. Are there any thoughts about this as a kind of protocol or a framework that you feel like sharing? And I know that was a lot.
I like this. My concern would be, how do we translate it to a grade for a student? So would this be a graded assignment then, probably? Because every time I turn around, like, a kid is like, but it is going to be graded. Is it for a grade? Is it, so I know for me, it's for them to practice doing mathematical thinking and explanations. But for them, they're like, well, why am I doing it then? So.
Yeah, I think what's been my experience is just even doing it 1 or 2 times. If you show them a couple different pieces of student work and they go, well, there's no numbers there. Like or there's no, what do those numbers mean? They will instinctually like internalize, like, oh shoot, what did I write? And often kids will be like, can I have mine back? I want to see what I wrote. Like, cause I know now that when she asks me to explain, I'm going to include these things. So it's more of kind of a activity and practice. You can use it as a grade if you want, if you think that will motivate them. But if you give them their first one and it's just an M and they're like, what? Oh my gosh. And you say, hey, add some words. What are you talking about? They're like, oh yeah, easy peasy. And then that's, I think it's more of a, we're trying to kind of build that muscle and just by giving them opportunities and because ultimately they do have to explain their thinking on the performance task in Smarter Balanced, and it's worth a lot. Not that that's the end all be all is standardized tests, but like that piece of it is very valuable. It's weighted more than the just procedural skill part. So if we can help them just even, oh my gosh, just make sure there's numbers and words in your explanation, that's going to help them. And also in the real actual world, which is how I started this entire thing. But I agree with you. They might need, if it's not a grade, they might need yeah.
And if you did want to transfer it to a grade, what Colleen had brought up, I think what would be extremely detrimental is if you sort of said like, well, it's either a 0 out of 3, a 1 out of 3, a 2 out of 3, or a 3 out of 3, because we have these 3 bins. Because obviously then you can only pass if you get an MCL, right? So I've seen teachers use like an A, B, C structure where it's like an MCL is an A, any 2 or 1 would be a B, and then like no attempt or no evidence could be a C. If you really felt like this, it has to be a component of the grade book, because otherwise you just bury kids in Fs. That's not fun. So, but yeah, really wanting to send the message to kids that it is about revision. It's about feedback. I probably wouldn't even score them the first time. I might lead them through a re-engagement lesson so that they can better understand what it is that we're looking for, give them another pass, and then score that one, just to, again, kind of message that it's about, your first draft doesn't have to be your final draft.
I kind of been tweaking the mastery grading learning in terms of giving 1 through 4s. And what I usually been doing lately is that I kind of give them the expectations, or say, I need to see evidence of your math. I need to see why you are doing it. And then I need you to tell me how your why. You need to explain it. And so that becomes a mini rubric, right? Yes. And so I said, when you are turning in the work, check if you got the 3 things I'm asking you. Because I cannot grade it in something they don't know. It's like doing like student-friendly rubrics. because now they know what is their expectation. They know what are the components that they need to be included. And it gives them more like key points, what to focus. And yes, at the beginning, they kind of get struggle, they don't want to do it. But then that feedback that you guys are mentioning, it's okay, Miss, can I do it again? Yes, it is a lot of work for us because sometimes they want to do it even twice or, or more than one time. But I find that turns into engaging later on, because if they did get a bad grade, they said, can I do it again? So that is a motivation, and is learning from their mistakes. So that is also, growing the muscle right here. So that had worked for me in terms of setting the expectations ahead of time. And I always give them the goal. So within the goal, I try to put that so they know what they're really targeting.
Oh, that's awesome. Thank you for sharing that. And I think it's important that we clarify for kiddos, like, what is it that we expect, right? And that will definitely help both parties in the long run. So we're almost out of time here. Just want to highlight some of the things that we have accomplished today with regards to technology, instructional strategies, and just-in-time or 8th grade content. And thinking back on all 4 of our sessions, Solana and I sat down and said, like, what kinds of problems of practice are we going to aim to address? We've got student engagement, sense making and solving non-routine problems, and then also oral and written communication. And we did our best to try to offer some strategies that can help support those problems of practice. And look at all the amazing things that we were able to talk about in the last 4 months. And hopefully you're seeing a lot of connections to those problems of practice and feel like, wow, I can really address student engagement, or I have some tools in my toolkit now that I didn't have before. So hopefully this has been a beneficial experience for you. Solana and I have certainly valued this opportunity to work with each of you. In terms of our guideposts, is that right? Yeah, guide. I always forget that word. We've covered a lot of really great stuff throughout the series, but also today looking at open-ended questions and error analysis, thinking about ratios and proportional relationships. We just want to say that this hopefully is not goodbye, but just until next time. We are going to host a little office hour optional if you would like. It will be on Wednesday, May 18th from 3:30 to 4:30 if you just want to stop by and say hello. Yes, I can, Bootsy. If you just want to come by and say hello, or you want to, share some of the rock star things that you've been doing since we last saw you, or things that you plan on using, or any sort of insights, we welcome you for that. Bootsy, is that good? Okay, perfect. So with that, Solana has just dropped in there for you a final survey, and then also your sign out survey. As always, one of those is to make sure that you get compensated for your time. So we know that that one's really important to you. The final survey is really important for us as well, because it's a nice opportunity for Solana and myself to kind of reflect on the four components of the series. But we know that for many, many reasons, this has been such a challenging year. But I can speak for both Solana and myself, as well as Patrick, that this has been a real highlight to connect with each of you, to learn from each of you. And, I'm like getting emotional just thinking about how much I'm going to miss you. And I get to see you on Saturdays. So that's how much I like you, is that, coming in on the weekends. So thank you so much for all of your incredible hard work, thoughtfulness, and your commitment to your students and your communities and your practice. You are all amazing, and please stay in touch with us.
I also dropped in that resource document for your reference. We will link this slide. I think it's the slide deck is already linked, but any other resources that we can think of, we'll always drop them there. You have access to this, to the previous sessions, and a recording of each of those. So if you ever feel like, wait, how did Jessica do Vanguard problems? We'll hang out for a minute, but you're free to go once you sign out. And thank you, everybody.